Hi, and welcome to my talk on errors in natural language generation output. This talk is scheduled as follows. So first I'll talk a bit about evaluation, the general picture, and then I'll move on to errors and error analysis. Then I'll be talking about the impact of different kinds of errors on users. And then I'll be talking about the adaptation of evaluation metrics. So not going to be talking about specific solutions, just some considerations of how we should adapt our evaluation metrics based on what I've told you in this talk. This talk was originally given in December of last year at the NL4XAI workshop, training event for young PhD students and people in the project on using natural language for explainable AI. First, some preliminaries, things that I think we can all agree on. Common ground. When developing a natural language generation system, you need to assess its performance. You cannot develop a system and then deploy it without knowing how good or bad it is. And this can be done in different ways. So you can do this during development to see if your system development is on the right track, or if you're training a model, you can see whether it's still learning to perform better. You can do this upon completion of the system to see whether you succeeded at building a useful model that actually generates usable output. And you can also evaluate the system after deployment. So when real-life users are using this, does it hold up in practice? Does it deliver on its promise? And for example, does productivity go up, or do people enjoy using the system? Does it hold up when the world changes? These kinds of things, right? You can look at many different perspectives here. And you can do this through either metrics, so standardized measurements resulting in a performance score or multiple performance scores. You can evaluate a model using human ratings or rankings produced by human judges, and these could either be experts or lay people. And you can use other forms of assessment. Now, this overlaps slightly with the previous two bullet points. So you can use error analysis, you can use focus groups, people discussing your system. You can carry out interviews with users or other stakeholders, and the list goes on. And I think these things aren't done as much, but I think they could be very promising, would be very interesting to get some more in-depth information about the performance and impact of a system on its environment. Yeah, so as I said, this is an underexplored area. People don't tend to use focus groups or interviews with deployed NLG systems, for example, or with people using deployed NLG systems. There are also some issues that we agree on. So there's a couple of big questions. One of those is, what should we actually evaluate? Because there are many different things that we could look at. And there's a very nice paper by Anya, Belz and colleagues trying to provide a taxonomy of different kinds of constructs that we can be looking at in an evaluation. So do you look at the fluency of a text, the naturalness of a text, the grammaticality, the adequacy of the text with respect to the input, and so on and so forth. There are very many dimensions that you could look at, and not all of them are always equally relevant. And you typically have to make a choice here. It's not like you can evaluate everything given a limited or finite amount of time. Another question here is, what should we take as a reference standard? What should the output look like? This is not at all clear. In fact, it's become more blurry now that we've grown to depend on neural systems now trained on large corpora instead of thinking of rules and thinking of templates for our outputs. Before, when building a rule-based system, you really need to carefully think about what should the output look like. And now sometimes you see that this is a bit underdefined, that it's left to crowd workers, for example, to figure out what a good output would look like. And I think it could really benefit us to think about this more. Another question, how extensive should our evaluation be? In my experience, this is often treated as somewhat of an afterthought. Having built this system, oh yeah, right, we still need to evaluate this. And people tend to go for a quick and dirty solution, even though this evaluation is essential. If this system is going to be used, you want to know that this system is reliable. But the question of, well, what exactly should the standard be? You don't see this being discussed as much. Although in recent years, especially at the INLG conference, people have come to emphasize evaluation a lot more. You see people being critical of evaluations a lot more. And I think this will only increase, because as these systems are being used more and more in a more different application areas, we need to know that these systems work as advertised. Then some further common ground: metrics, ratings, and rankings can be under-informative. It's unclear what scores and rankings mean for the quality of the output. So if you get a blue score of 30, or if you get a fluency, average fluency for your output of a 4 on a scale from 1 to 5, for example, what does that mean? What does the output then look like? This is very unclear. It's also very unclear how to improve systems based on this kind of feedback. Because, okay, now the system has a score of 30 or a score of 4 or a score of 100. How could you make your system perform any better? This is unclear, right? Based on just a number, you don't know how to improve your system or where to improve your system. And this, I think, generates documentation debt, which is a form of technical debt, meaning that the systems that we build and that we evaluate and that we consider basically done and we move on to the next project are under-documented. We don't know much about their performance other than these numbers. And so it's very hard to think about how we can improve on these systems in the future. I would argue that error analysis and other more qualitative approaches can provide meaningful feedback, and they may inspire future benchmarks and improvements. Once you know what the weaknesses of a system are, then you can start thinking about developing benchmarks to target those weaknesses. And you can think of specific improvements so that you can actually make the system stronger in that respect. Okay, so now that I've mentioned errors, let's talk about errors. In some previous work, we defined errors as countable instances of things that went wrong, as identified from the generated text. And this allows for two kinds of errors. You have one kind that I would like to call universal errors, gross inaccuracies, things that are just wrong, factual errors. And you also have task-dependent errors. So it's not wrong per se, and an NLG system producing this kind of output is not wrong in any way. It just doesn't match the goal of the developer. For example, if a system produces very informal text, when you wanted to produce formal text, there's nothing wrong with the text per se, it's just not appropriate given the context. This is not the style that we are going for. So for this particular task, this is not what we want. And one way to identify errors is through error analysis. In error analysis, we also provide a flowchart in this paper, is a process where an iterative process where you have annotators going through the output of an NLG system and identifying, often manually identifying errors in the output and trying to classify them according to some kind of taxonomy. I will not go into depth and explain this full flowchart because we just don't have the time. I'd like this to be a relatively concise talk, but if you're interested, please see this paper. Now, for some examples of errors, so here's a summary of a game. I think this is a basketball game, but I don't know. I don't know US sports that well. But okay, let's assume that this is a basketball report. And then the authors, Craig Thompson and Ehud Reiter, identified different errors in this game summary that was produced by some NLG system. And they have different kinds of errors that they've identified. Things like the incorrect number. So the score was actually 5-0 instead of 5-2. Things like incorrect named entities. Monday or Talking Stick Resort Arena. These should be different, a different day or a different place, for example. Right. So they categorized all these kinds of errors through a taxonomy that they've developed themselves. And we also looked into these kinds of things. Here's an example image description generated by a system. You don't need to read the entire slide, just look at the bottom. Then there's an NLG system, an image description system saying a girl is wearing a red shirt and she's holding a tennis racket. Well, if you look at the image, then this girl is clearly not wearing a red shirt, but a blue one. It's not really a girl, it's a slightly older person. All the human describers say this is a woman, and she's not holding a tennis racket, but she's holding a piece of cake. So this system actually makes 3 mistakes or produces 3 errors in one sentence. Now, we've carried out a study trying to look at the individual impact of different kinds of errors. And we call this error severity. With the main question, well, do all errors have the same impact? Well, likely not. Some errors are probably bound to be perceived as less harmful or less severe than others. But how does that work, and how can you study this kind of thing? Well, we looked at minimal pairs, extremely minimal pairs in this case. So we had Chinese examples differing by only 1 Chinese character. So not even word, this is at sub-word level, changing 1 character in the output and otherwise having identical descriptions of the same image. So the reference description says that this is a man in a yellow shirt playing tennis on a tennis court. And we have 4 different kinds of errors. So either a woman wearing a yellow shirt on a tennis court playing tennis, or it's a boy, then this is an age error. There's a clothing error saying this is a coat instead of a shirt, and a clothing color error saying this is a purple shirt instead of a yellow shirt. So otherwise, these sentences are exactly the same. And we've asked human raters to look at these descriptions and then provide a score, saying, okay, on a scale from 0 to 100, what do you think of the overall quality of this automatically generated description, given that the correct description is as stated above? And in our experiment, we used multiple different images, also to control for those. And what you then see is that there is indeed a difference in the mean score that is given to these descriptions. And then we carried out some statistical analysis. You don't need to understand this table. The main takeaway here is that we do find significant differences in the ratings that people give to these different kinds of errors. Okay. And as I said, by design, these minimal pairs differ by only 1 character. And metrics like Blue and Meteor always produce the same scores for erroneous outputs. So if it differs by 1 character, then metrics will give all these 4 descriptions. a penalty, but it's always the same penalty. They don't distinguish between different kinds of errors. And what we've seen now is that humans respond differently to different kinds of errors. So there's this contrast between how humans tend to treat erroneous output and how these established metrics treat erroneous outputs. So this gives rise to a number of questions that I've here described as avenues for future research. First question would be, well, what about other tasks? Do we see the same pattern or the same behavior in other tasks, that different kinds of errors consistently, or at least usually get different scores than others? And do we also see differences in human error perception? So do we see differences across cultures, or what about individual differences, and so on? And also, what about learned metrics? So I've talked about, or I've mentioned the blue and meteor scores, but obviously there are other kinds of metrics that are trained to predict ratings that are produced by humans. So these learned metrics in some way might have incorporated some knowledge about error severity. Well, then it might be really nice to inspect those learned metrics and to see what they have learned about how humans judge different kinds of errors. So can we open up the black box? Can we make learned metrics a bit more explainable by saying, well, this sentence gets a lower score than this one, or this text gets a lower score than this one, because there's this and this kind of mistake in this text, but not in that one. Or, yeah, that text does contain some mistakes, but they're not really bad. They're okay. They're just small mistakes rather than the big ones in the other text. That's the kind of questions that you could ask for these learned metrics. And also, we can do this the other way around, right? We could think about ways to improve existing metrics using these different kinds of error taxonomies that exist for different tasks. So if you know that systems could, in theory, make these different kinds of mistakes, how can we incorporate that into these metrics and just have the metrics detect different kinds of mistakes? Possibly associate them with different scores, but you could also just think of an error classifier without saying that, without tying this specific error to a specific kind of score. Or could we replace metrics altogether? Or should we replace metrics altogether? Just always thinking about this in terms of errors, or so in terms of error analysis or error detection performed automatically. Okay, so moving on to a different topic, slightly different topic. So how can we apply this knowledge or these ideas in the context of the NL4XAI project? So the aim of this project is to have natural language generation systems produce explanations of decisions made by machine learning algorithms, basically. Okay, so an example task here would be explaining a decision made by a classification model. And one example from the literature is expliclass. And here's an example. So it says, okay, this beer, and they have a database of different kinds of beers, is a type of porter because its strength is standard and its color is brown. However, this beer may also be stout because its color is quite close to the usual stout value, and for these specific values, it's just as likely to be stout. But stout will be an exception because class porter is confused with stout only in 2% of cases. Okay, so this is the kind of output that the system might produce. And then you could think about, okay, what kinds of errors could this system produce, right? So maybe the output could just be factually inaccurate. It could be a porter instead of a stout. There could be a value error. It could say 30.45 instead of 42.30 or whatever. It could say brown instead of amber. and so on. And these are relatively easy to detect. So if the NLG system produces or uses some value in the text and the value is factually inaccurate, we could find this by comparing the input and the output. But there might also already be some challenges here, right? You could have rounding errors, fuzzy language, so not exactly reproducing the input, but approximating the input. If it approximates the input, then it will already be a challenge to detect. What about context? What kinds of aspects should we consider here? So are there specific requirements from users? So how would they feel? What would they like the descriptions or the explanations to look like? Are there any existing guidelines that we could use for these kinds of descriptions? And what is the impact of errors on performance, or what is the impact on the performance of people using this system? And are there any ethical considerations that we should keep in mind when developing this kind of technology? Okay, so for users, I can imagine that there would be different types of users. There could be machine learning developers, professional users, and lay people, and they could have different frequencies of use. So maybe a person would use this NL4XAI system very intensively over a short period of time. Or maybe they would use it daily for a longer period of time. Or maybe they would just use it occasionally. Well, depending on these two factors, we could think of different things that are important to them. So depending on their experience, we should either use or avoid specific terminology. And depending on the frequency, so you wouldn't use very specific machine learning terminology with lay people. That is probably a bad idea. Or depending on the frequency of use, if you have a power user, and there's, for example, this work by Ehud Reiter and others on generating weather reports for people who work on oil rigs, these people love consistency in energy output, because then they know with every turn of phrase what kind of weather is associated with that verbiage. If you always use the same language for the same situation, then people know what to expect, and it's very nice if the system is predictable like this for professional users. Others may just find this boring in other applications, so it depends also on the context. So if you just have people sitting in the car and listening to the weather report, they might not want to have this super consistent terminology, but they might appreciate some variation. But for professionals, for these working on oil rigs, they love consistency here. Using this system more frequently, if the output is very consistent, they might also be more productive because they know exactly what is going on. Well, as a consequence of these considerations, we may want to test the model for these properties. Is the model indeed consistent? Or does it use or avoid specific terminology? And moving on to other standards. Now I'm drawing on my knowledge of image description a bit more. So the Diagram Center, for example, offers standards for describing images in an educational context. And the World Wide Web Consortium does the same thing for online images through the Web Content Accessibility Guidelines. So if you have a table, for example, in a maths book, or if you have a picture on a website, then these are the guidelines that you should be conforming to. And if you want to evaluate the performance of a natural language generation system, then you should reference these guidelines. And you should also think about these guidelines when evaluating the system. Okay, so here we have a diagram, and this is a double bar graph. And the diagram guidelines say, okay, you should explain the data on the x-axis and y-axis and summarize the overall trend. You should list the data in bullet form, use the appropriate vocabulary in context with the surrounding text, and so on, right? And then at the bottom, you can see the description. A double bar graph shows corn and soybeans crops harvested from 1952 to 1982 in millions of bushels. Both crops increased steadily, blah, 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 and so on. And then there's the bullet points with the actual numbers. these are the standards for how you should describe a double bar graph. If you have these standards, then it's very nice. You can just see if your model checks the boxes, and you can check for compliance, right? So does the output have the desired properties? And I think this has a huge benefit because this is partially independent from the input. You don't even need to know what the input looks like or whether the output exactly matches the input. You just need to know whether the form is correct. And any deviation here is an error. And and I think error severity could here be thought of as, to what extent does this form a barrier to the interpretation of the graph? Thinking about the requirements for the descriptions helps us think about how to evaluate a system producing descriptions of these graphs. And for guidelines for these NL4XAI systems, I leave this as an exercise for after this talk. Okay, so maybe for some cases there are existing standards, but then standards shouldn't be taken as absolutes. So they come with caveats. And here's an example. So here's a reference on how to use particular terminology. The European Commission has a standard for communicating frequency of adverse effects of drugs. So if the frequency is 1 in every 10 cases, then you should describe that adverse effect as very common. Now, if you, and you can look at the table and look at the other terms and their specific frequencies, right? So there's very common, common, uncommon, rare, very rare, and not known. But when you give these terms to lay people, very common, common, uncommon, rare, and very rare, they're often misinterpreted by lay people. They don't associate these labels with these specific values. They might have a completely different understanding of these terms. So for professionals, these guidelines work. They're very fair. For lay people, they might be super confusing terms to be using. And here again, here's an approximate probability scale recommended for harmonized use in the European Food Safety Authority to express uncertainty. And here you have a very specific table for how to use these probability terms. And again, these terms are also often misinterpreted by lay people. So when you look at actual people, here's a distribution of the numerical interpretation given by lay people to probability terms or frequency terms. So you see that always has a distribution that's covering 100%, but it also covers 90%, for example. So if someone says always, a layperson might interpret that as in 90% of the cases. In 10% of the cases, things might be different. And the same thing goes for impossible. Something that is impossible literally means that this never happens. But when you look at the distribution, some people will think, well, in about 10% of the cases, this might still happen. And some of these terms have a very, very broad distribution, right? So often, for example, seems to range from about 50% to almost to 100%. That's a very big spread. So when you look at how lay people use these terms for these probability phrases, this deviates from the guidelines. So you need to keep this in mind, that there are different groups of people, and some of them will know the guidelines and interpret values that you provide with those guidelines in mind, and others will just not know the guidelines and have a very interesting interpretation of the output that your system provides. Okay, so getting back here to errors, what actually constitutes an error? So you can think of this as these terms being either right or wrong according to the guidelines. But you can also think of the situation where the probability term and the frequency term is used correctly, but is misleading for lay people. And what counts as an error, I think, depends on the audience. So if people misinterpret your output, that could be very problematic and thus be an error. but it doesn't have to be the case. And next to these things directly being an error, you can also think about your system output in terms of the impact on human performance. So think about what users are trying to do. Are they trying to understand a specific output, understand the relation between variables, and so on? Well, depending on the task that they want to perform, that will put an emphasis on different parts of the output of your natural language generation system. And that will also mean that errors in that specific part will also be more severe in their experience, because they really need this information to be correct. So consequently, the same error could have different associated levels of severity, depending on what users are trying to do. Okay, so this also brings us to harms that could arise from a model. So questions that you can ask when evaluating a model are things like, can the model cause harm in the real world? So will users attribute outcomes to the wrong factors? Or if your output is technically correct, but the output is very misleading, will people act on this information and act wrongly because they are misled by the system? And this is separate from the perceived severity on the part of the user, because they might not realize these harms, right? They might see the output, take it for granted, and then act upon this information. Then this is not the error severity as experienced by humans, or at least not immediately. But it is a harm caused by the model, and you also need to take these kinds of situations into consideration for a full evaluation of an NLG model. Okay, so that's a lot of information to take in. What next? Where could we be heading in the future? Well, as a starting point, I found this really nice paper in preparing for this talk. So Liao et al. Explored the importance of different properties in explainable AI. I don't have time to go into the definitions of all of these, but there are many, many different properties that you can judge an explanation on. So faithfulness, for example, coherence of the output, they're relatively self-explanatory. Others are a bit more difficult, things like translucence. So the paper is really a good reference for this. But what I really like about this paper is that they compared experts and end users in different application scenarios, so situations where explainable AI could be used, and explainable AI usage contexts. These are goals that the user has with the explainable AI system. So this really nicely matched the slides that I already had written. So it really came together nicely here. But they go in way more depth. So it's nice that they already did this work. So here are the explainable AI usage contexts that they envision. So things like model improvement. Can we improve how the model performs? Capability assessment, decision support. So to what extent does this model, or does this help us make better decisions? Model auditing, so can we understand what the model does, and so on. The setup for their experiment is described on this slide, right? So for each task, participants were asked to rate the importance of 12 evaluation criteria that explanation should satisfy for them to accomplish the task. And all responses are 5-point Likert type, from not important to very important. And here you see that context matters. For different tasks, different properties are more or less important, or at least so the participants say, right? You could look at this in more depth, maybe have them actually perform tasks based on this, rather than imagine that you had to carry out this task, for example. So more research is needed here, but the table already is very insightful. So what you see is that faithfulness to the input is not always at the first place, right? For model improvement, yes. But in other situations, it could be ranked 4th. for example. So you see that these different dimensions you can use to evaluate the model. Their ranks differ depending on what you want to use the output for. Okay, so moving on to the final part of the presentation, things that I don't really have time for and also haven't really quite figured out. So what I've not seen yet, but what I'd really like to see and what I'd also really like to work on is this theory of human evaluation for energy output evaluation. So what I mean by that is that if you ask a human judge to give an overall quality score to some energy output, there's a huge array of different variables that they take into account. They look at the grammaticality of the output, the fluency, the accuracy, that could be numerical, that could be verbal accuracy, the brevity, appropriateness, all these dimensions. They make up the overall quality in some way. And that, of course, also depends on the task and the context, and also on individual differences in the background of your user and so on. So the question is, okay, how do they relate to each other? How is this overall quality score built up? How do people interpret text, and how do they process this and come to some overall quality score? I find this fascinating, and I think it would be really valuable to try and model this process. And I haven't seen this yet, but I'm endlessly fascinated by this. And I think, wow, wouldn't it be nice to have some cognitive model of human interpretation and processing of energy output? I know there's a lot of work in linguistics on how people process texts. It would be nice to extend that work and also think about the appraisal of automatically generated texts. And here, one association that I have is also that of optimality theory. So there could be different output rankings based on soft or hard constraints. So one hard constraint, for example, could be accuracy, right? So all other things being equal, a text that contains errors, things that are just plain wrong, is always worse than any other kind of text. And then there's also softer constraints, things like suitability for the audience. Well, maybe a text is less suitable, but if you look at all the other benefits that this text has, okay, maybe it's still a better text than another text that is more suitable for the audience. So you could have a worse suitability, but still be a better text. And optimality theory does seem to provide a nice framework for thinking about the quality of a text that a model produces. I don't know what to do with that association. I'm just putting it out there because I think it's nice to make these associations and maybe talk about this more of, okay, how do people actually determine the quality of a text? Okay, so in summary of this talk, errors for me are countable instances of things that went wrong in the generated text. And we can identify these errors through error analysis. And error analyses produce different things. The full process of error analysis, if there's not one already, also gives you a nice taxonomy of errors. What are the different kinds of errors that are made by the system? It gives you frequency counts for different kinds of errors. And it also gives you small corpora of annotated texts. And I think those could also be a nice resource for future research in this topic. So if we have a small corpus of annotated texts and we also collect ratings for different automatically generated texts, then we can also see what the impact of different errors is on the eventual judgments that people provide for these texts. Some errors are universal, so these are just gross inaccuracies, for example. But other kinds of errors are task-dependent. They're relative to a standard. Depending on the goals that you might have with your NLG system, this might be very bad, or it might still be fine. But both kinds of errors influence perceived quality. And both kinds of errors have subtypes which differ in their impact. So they have a different perceived severity. And different evaluation metrics, so blue and meteor, are demonstrably insensitive to differences in severity. Now, for explainable AI and explaining how machine learning models work using natural language, there's also clear and unambiguous errors, but much depends on the context. And I think this holds for any problem. So if you're watching this video and you're not really into explainable AI, then I think this is still relevant, right? You still need to think about requirements from users, existing guidelines. Is there anything out there for you? Some standard of what a good output text should look like? Is this something that you've also developed for yourself for a crowdsourcing task, for example? Or are there already organizations that provide these guidelines? Well, maybe we should think about operationalizing these guidelines into specific metrics, targeting those guidelines. And we can also think about the quality of the output of an NLG system in terms of the impact of that, the quality of that output on the performance of human users. And we need to always think of the ethical considerations here. So how the system is going to be used and what the implications of deploying an NLG system are. Also keeping these errors that still do happen in mind. And answering these questions enables you to carry out targeted evaluations. So we need to be more specific about all these requirements that exist and the context of use for NLG systems before we can really carry out an appropriate evaluation for NLG systems. And that's all I have. So thank you so much for watching this video. And if you have any questions, feel free to contact me.